All right, this is section 5.6, exponential and logarithmic equations. So first we'll start with solving exponentials. To do that, we want to isolate the exponential expression, try writing both sides with the same base, and we may need to rewrite the equation to finish solving it. All right, let's zoom in here just a little bit. All right, let's try number one first. So number one first, I can write each of these as a base 2. So this will be 2 squared. That's 4, to the x plus 3 equals 2 to the third, that's 8, to the 2x minus 1. Okay, if you remember how to apply when you have two different exponents, 2 to the second and then to the x plus 3, you just multiply the two exponents. So this will be 2 to the 2x plus 6. Notice I just multiplied 2 times x plus 3 equals 2 to the 6x minus 3. Again, I just multiplied the 3 times the 2x minus 1. So if it's the same base, then the exponents have to be equal. So 2x plus 6 has to equal 6x minus 3. Yeah. I'll subtract 6x. Let's write that down so we can see it. Minus 6x. That'll give me negative 4x plus 6 equals negative 3. I will subtract 6 then. So I have negative 4x equals negative 9 and divide by negative 4. And so I get x equals 9/4, and I can leave it that way. I don't need to write that as a decimal. And that's my answer. Notice I can plug it into my original equation to check if I have the right answer. All right, let's try number 4. So number 4, first we have to isolate the exponential. Remember, that's the very first thing we have to do. So this one is not isolated, it's 5 times the exponential. So I'm going to divide by 5. And so I have e to the 1.5x equals, and 7.2 divided by 5 is 1.44. Let's double check that on a calculator. All right, so I checked that it is 1.44. All right, so I'm going to write this as an exponential, as a logarithm, right? So the base is e, so I'm going to take log base e, ln of 1.44 should be equal to the exponent 1.5x. Notice I'm almost done solving for x. I will divide by 1.5. Okay, so this will be x equals, notice I have now x equals ln of 1.44 divided by 1.5. And that's my answer, unless I need an approximation, right? If I need an approximation, I just punch that into my calculator. So this will be approximately, again, notice that's if somebody makes me do it. Okay, so ln of 1.44 divided by 1.5, and I get 0.243 approximately, if I need an approximation. All right, let's try number 5. Number 5 says 4 to the x minus... Oh, before we try number 5, let's think of number 4 a different way. So I want to think of number 4 a different way. I'm going to start right here. E to the 1.5x equals 1.44. You always have to isolate the exponential, okay? E to the 1.5x equals 1.44. Okay, but I'm going to think of it instead of writing it as an exponential, taking the logarithm of both sides, any base I want. And because it's the base here is e, I'm going to take log base e of both sides. Okay, so my next line is going to be ln of e to the 1.5x equals ln of 1.44. Okay, now how do I find ln of e to the 1.5x? Remember, this ln is base e and this expression has a base e, so that just simplifies into 1.5x, right? Ln of e to the 1.5x is just 1.5x equals ln of 1.44, and then I'm just going to divide by 1.5. Notice I'm still getting the same answer. We just wanted to see that you can think of it that way, that you can think of taking the logarithm of both sides, as long as you can take the logarithm of those numbers, okay? So that's a positive number, greater than 0, that means I can take the logarithm any base, okay? Same answer, yeah? All right, so the reason I wanted to show you that is because when you get to number 5, I don't have a single base. I have two different bases, and I can write cannot write them in terms of the same base. So what I'm going to do is just take a logarithm, any logarithm I want, and I'm going to do ln because usually you see ln or log base 10. So this will be then ln of 4 to the x minus 1 equals ln of 3 to the 2x. Now where do I go from there? Well, remember when you have a logarithm of a number with an exponent, that exponent can move out to the front as a coefficient. Okay. Same thing with the other one on the other side. I can move the 2x right here. Okay. So I have x minus 1 ln a 4, right? Because the exponent moved out, equals 2x ln of 3. Okay? All right. So I'm going to distribute on the left. Remember, this is x minus 1 ln of 4. ln of 4 is just some number. You can punch that into your calculator to see what it looks like, but I'm not going to do that yet, okay? Because otherwise I'm just going to have to round, and I don't want to do that yet. So when I distribute ln of 4 times x, that's x times ln of 4 minus 1 times ln 4, that's just minus ln 4, equals 2x times ln of 3. Got to remember, ln of 3 is just some number. It's kind of like saying the square root of 3, right? It's just some number. All right, now I want my x's on the same side, so I'm going to subtract 2x, right? Subtract 2x h to 2x ln of 3 from both sides. And I'm going to add ln 4. Okay, so that'll cancel that right there, right? Plus ln 4. Right, and this one canceled that right there. Okay, so I have x ln 4 minus 2x ln 3 equals just ln 4. Yeah? All right, so to get a single x, I'm going to factor out the x. This will be x times ln 4 minus 2 ln 3. Remember, I factored out the x, equals ln 4. And then I'm just going to divide by ln 4 minus 2 ln 3, divide by this right here. ln 4 minus 2 ln 3, divide by ln 4 minus 2 ln 3. And I have x equals that, ln 4 over ln 4 minus 2 ln 3. And that's an exact answer. And then if I want an approximation, I just type that into my calculator. Let me do it and see what I get. And that's about approximately negative 1.71. Rounded to nearest hundreds. It goes further, of course, if you want to round it later on. Okay? All right. Let's try number 7. 4 log base 3 of x equals 8. Oh, this is a logarithmic. So we want to isolate the logarithmic expression and then rewrite using definitions and properties. And then make sure we check for extraneous solutions. I mean solutions that don't work. Okay, so first I'm going to divide by 4 to isolate the logarithm. That's log base 3 of x equals 2. And then I'm going to rewrite as an exponential. So 3 to the second equals x. So x equals 9. All right, I'm going to plug it into just to check it. Log base 3 of 9 will be 2 times 4 is 8. Okay, good answer. All right, let's see what we got on the next page. All right, so this one's word problems. Let's do at least one. So the first one is, an investment of $880,000 is losing 3% of its value each year. How many years will it take to lose half its value? Round to the nearest tenth of a year. So remember we had a function, right? It was like v of t, the value at a certain time t is 180,000, the initial value, times 0.97 to the t power. Yeah, remember it's 0.97 because it's 97% you're keeping each year. All right, so now we want to know when will this value be half of the 180,000. So we will replace the v of t with 90,000. That's half of 180,000. Equals 180,000 times 0.97 to the t. Remember, we're trying to find out how many years will it take. That means we're solving for t. All right, so first I'm going to isolate the exponential. So I divide by 180,000. All right, and this is half, and I can leave it as half or I can use 0.5 because it's the same thing, okay? So 0.5 equals 0.97 to the t power. All right, so again, I'm going to just take the natural log of both sides. You can take any log, or you can write it as an exponential. All right, so this is going to be ln of 0.5 equals ln of 0.97 to the t power. So the t power is going to come out to the front, right? Or we're going to move it to the front, right? And get away from there. So I have ln of 0.5 equals t times ln of 0.97. I divide by ln of 0.97. Remember, I'm just solving for t. All right, and I get t equals ln of 0.5 over ln of 0.97. Now, remember, that's an exact answer. They asked us to round to the nearest tenth of a year, so they're telling us we want an approximation. So I punch it into my calculator, and I get about, rounded to the nearest tenth of a year, I get 22 point, and I get 0.75657, etc. So it's about 22.8 rounded to the nearest tenth. Okay, so t is about that much. Okay, all right, and I think I'll leave it at that. We have 3 more problems to work. We'll work those in class, and we'll work the equations that we haven't done on the other page also in class. All right, so I'm going to stop there.